Here students, today I Prakash Birla, Assistant Professor, MLV Textile Institute, Bhilwara, going to discuss the one of the most important high performance fiber, that is the carbon fibers. In the history, the carbon fibers first used as a bulb filament by Swan and Edison in 1879, and from that period to 60 to 70 years later on, no serious efforts were carried out by many of the researchers. But in the later years, as the demands comes, say lightweight reinforced composite materials, and after that the some leading countries, say like US, Japan or England, go for some serious efforts using the different type of starting taking the different type of starting materials. And you can say here, for the production of carbon fibers, they are the three major precursor materials. Say one of the viscose rayon, polyacrylonitrile and pitch, which comes from the petroleum refineries, west of the petroleum refinery. And in the production of the carbon fibers, there are the three major steps. One is the oxidative stabilization, another is the carbonization, and third is the graphitization. First, to discuss the carbon fibers from viscose rayon. The carbon fibers from viscose rayon first were carried out by the US based space agencies, and they use the three different stages: oxidative stabilization, which is carried out at 200 to 300 or sometimes more than 300 degrees centigrade, and viscose rayon fibers are in presence of air or oxygen get stabilized or heated and finally oxidized. The oxidized viscose rayon fibers go for the further process of carbonization, which is heated at above 1000 degrees centigrade to the level of 1500 degrees centigrade, and this process is carried out in tension, because it is worth noting that at the time of heating the shrinkage takes place, and this shrinkage results in the disorder of the preferred orientation, which were already present in the fiber, get disordered here, you can see. And finally, after the carbonization, the graphitization takes place, and the fibers such results is having low strength and not the enough modulus. So that's why the carbon fiber produced from the viscose rayon is not considered as a, you can say, the high performance fibers for particular applications or high technical and applications. Pain based carbon fibers. This pain based carbon fiber first were carried out by the Shindo, the name of the researchers which were from Japan, and but the fibers produced by him did not show the properties required for the high performance applications. But in later years, in parallel of that, in England, the group of scientists, say Watt, Johnson and Phillips, got work for the Royal Aircrafts for Farnborough, England, got the success to manufacture a carbon fiber for high performance application, and there are the three following stages used for the carbon fiber production. First is the oxidative stabilization. The acrylic pen fibers were heated in air between 200 to 300 degrees centigrade, and during this a controlled shrinkage, means by applying a slight tension and allowed They control shrinkage during the heat treatment and also ensure there is a no disorientation occurs or no shrinkage results during the heat treatment. The presence of the highly polar the highly polar nitrile group, that is C triple bond N, and on every second, this is available in on every second carbon atom in the polymer chain, which convert in linked hydrogenated naphthyl pyridine rings and increases the thermal stability of the polymers, since it prevents the easy formation of the small volatiles. And also during heating at above 200 degrees centigrade, some cationic groups are also formed by the oxidation of CH2 groups by the oxygen presence in the air. And you can see here the reaction occur, and a acrylic polymer which is heated at 220 degrees centigrade in this diagram, and during this the dehydrogenation and cyclization takes place. Carbonization. The black oxidized fibers is now heated slowly to a high temperature of 1000 to 1500 degrees centigrade in an inert atmosphere. Yes, it is important to note that oxygen must be removed from during the processing, and this process, carbonization process, is carried out in under tension but without stretch. Means tension is only, do not allow to shrink, but not cause of the any stretch. And during this process intermolecular reaction occurs and give some cross linking between the you can say the some rings formation or planar sheets are start to form here, and these reaction proceed via elimination of the low molecular gaseous products. Mainly the low molecular weight gaseous products are the carbon monoxide, carbon dioxide, HCN, ammonia or hydrogen gas is evolved from during the process. And because of the elimination of these gaseous mass, the finally the 50% by weight the yield of carbonized fibers results, and their original weight at this stage fiber contains mostly the carbon and some nitrogen atoms. Carbon atoms are connected in ring structure and planar sheets are formed, but perfect order is yet not achieved. Yes, the ordered structure which is required to produce a finally high modulus fiber is in this stage, means at the second stage of carbonization, is not achieved. Carbon filaments have relatively low strength and low modulus. You can see here in the diagram here the naphthalene pyridine rings at high temperature from 1000 to 1500 degrees centigrade. First the hydrogen and other gaseous matters evolve and convert in a small planar sheets, and further heating or increase in the temperature, which the small planar sheets start to convert to big planar sheet planes of the carbon ring structure, which is having mostly the carbon and some amount of nitrogen in the structure. Now, third step for the carbon fiber manufacturing, the graphitization. The carbonized filaments are subsequently heat treated at temperature of 1500 to 2700 degrees centigrade, and during this treatment their structure becomes more ordered and turns towards a true graphitic form. With increasing heat treatment temperature, the graphitized filaments attain a high tensile modulus, but their tensile strength may be relatively low, and this can be further improved by stretching. Yes, strength further can be improved by stretching. 30% stretch can be imparted during the processing, and the stretching is carried out about 2000 degrees centigrade temperature. Some other physical properties can be improved. Yes, with the improvement, mechanical properties as well as physical properties can be improved by eliminating some packing or defects and improving the order. And you can see the diagram here for carbon fiber manufacturing. First step is oxidization, second is carbonization, and third is graphitization.